So no foundation of physics will be complete without just a short little review on trigonometry. Hopefully this is something you guys all have on lockdown, but if you don't, I just want to remind you that we have this wonderful tool called SOHCAHTOA, okay? So this is a little bit of a trig review. Go ahead to the slide that says trig on top, just like that. And let's make a little triangle here, okay? A little right triangle. And so we have this wonderful little relationship that's always useful and always helpful, and man, are we going to use it a ton of times in physics, so just get ready for it, right? So let's imagine that we have a little triangle here, right? And we're going to call, this angle theta, right? And we're going to call this the hypotenuse, which you guys hopefully know. It's the longest side across from the right angle. And we're going to call this opposite because it's the side that's opposite of the angle. And we're going to call this adjacent because that's the side that is adjacent to the angle, right? Okay. And so we have this wonderful little relationship that the sine of this angle is always equal to opposite over hypotenuse. So that's opposite over hypotenuse, right? And the cosine of this angle is always equal to adjacent over hypotenuse. And then the tan of this angle, the tangent of this angle, is always equal to opposite over adjacent. And so that's where we get this famous thing called SO. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then TOA, tangent, is opposite over adjacent. Okay? And this will probably be the most memorable word from your high school career. It's definitely mine. And I will never forget it. And you will never forget it because you're going to have to use it in physics a ton, okay? And so let me just give you an example of how something like this might even come up. It comes up a ton with vectors, but I have this example of finding the depth of a body of water, okay? So if you guys will go to the slide that says finding the depth of a body of water, and I'll read really quick. It says a lakefront drops off gradually at an angle, right? So we have this little situation right here where we have, here is the lake, right? And we have this water up above here. We have this surface of the water, and we have this little boy on this boat. Okay, you're gonna find that I absolutely am terrible at drawing, and I'm not gonna let that stop me, guys. I'm not gonna let it stop me. So here's what we know. We know that actually I'm gonna draw this a little bit farther out like this. So we know that there's some angle theta here, right? And we know that where this guy is, he's at 2.25 meters, right? And that somewhere out here, there's some depth that we want to know, okay? And so the question first is, what is the value of theta, right? Well, here's what we know. We know that this boy in the boat is 14 meters out. Okay, at this point here, he's 14 meters out. So we have a right triangle here, right? I mean, within the limits of my terrible drawing, we have a right triangle here. So if I want to find this angle, then I'm simply just going to do the tangent of opposite over adjacent, right? This is my hypotenuse. This is opposite. This is adjacent. So I know that tan theta is equal to opposite over adjacent, right? And in this case, tan theta is going to be 2.25 divided by 14 meters, right? Which means that theta is just going to be tan inverse, just a function you do on your calculator. You can do that on your little TI, 80, whatever, 90, whatever, right? And you have 2.25 over 14 meters, and I get the lovely little answer of 9.1 degrees, right? So this lake will slope off at 9.1 degrees. And the beautiful thing about finding that, guys, is that now I can use it to find the depth anywhere else using this trig function, right? So let's say now part B says what would be the depth of the lake a distance 22 meters out, right? So now this is my new triangle at 22 meters. Okay, so in this case, I want to use the same formula. I want to use tangent theta equals opposite over adjacent, except this time I know my angle. The angle is 9.1 degrees, right? And I want to find my opposite, which is d, the depth at this distance, and my adjacent, which is how far I'm out into the lake, is just going to be 22 meters. So in other words, d is equal to 22 tan of 9.1 equals, I get 3.5 meters. Does that sound right to you? Let's see. We know that here the depth is 2.25 meters. So would it make sense that it would be more deep here, 3.5 meters, right? At least a little bit more deep. So the fact that this is bigger than this lets us know we maybe have done this problem right. And the fact that this isn't hugely bigger than this, like if this were 350 meters, you might want to check your answer again, okay? But for what it's worth, this looks pretty good to me, okay? So hopefully that makes sense. Check in with me if it doesn't. If you guys could go ahead and advance to the slide that says misconception question up with the tree. And it's about a tree in the Redwood National Forest called Hyperion, which is actually the highest tree in the world. And while I'm erasing here, I'll read. While trudging through the Redwood National Park, you stumble upon Hyperion, the world's tallest tree. You look up at a 45-degree angle and approximate that your eyes are about 500 feet from the top of the tree. How tall is the tree? Okay, here's an example of a question where you want to draw a picture. And when I say here's an example, I mean do it for every single problem, guys. Every single problem, draw a picture. I am always drawing a picture. As you can see from my last example, I drew a picture. I'm always drawing a picture. I've been doing this for like 3,000 years and I still draw pictures all the time, right? So here's the thing. I'll do this in green because it's a tree. So I have this cool tree, right? Okay, and I am over here, okay, and I am some distance away from the tree, and I am looking up, okay, and then I'm just gonna say that this is my distance away from the tree also, right? And then so there must be some theta there, okay? So the question is, you look up at a 45-degree angle, it's telling you this is 45 degrees, right? And you approximate that your eyes are 500 feet. Your eyes are 500 feet from the top of the tree. So this distance here would be 500 feet. Do you guys see the value of making a picture so much more clearly, right? And so how tall is the tree? So we want this height, right? Now, we're going to assume that the height of me is actually very small compared to the height of the tree. So whatever we get for this is going to be the height of the tree, all right? So what do we do, guys? Well, we have an angle and we have a hypotenuse, but we want to find the opposite. Sounds like sine to me, right? Okay, so let's take it. Sine theta equals opposite over hypotenuse. Okay, that means that sine of 45 is going to be equal to 500. Sorry, no. It's going to be the height divided by 500. So our height is going to be 500 sine 45. So height equals, what am I getting? 350 feet. Okay, the height is 350 feet. Technically, we could add to that however many feet I am. So let's say I'm 6 feet tall. That's 356 feet. Okay, we just use trig to approximate the height of this tree. And obviously I do this every time I'm hiking, guys, which makes me a real big nerd and no one wants to hike with me. That's why. Shoot. Okay. All right. So I always like to end these problems by going back to the why do we care and answering the why do we care question. If you guys remember, the why do we care question was, what would be the age of the Galapagos turtle in hours, right? A Galapagos turtle that was born in 1809. Okay, well, you guys can all solve that problem. And maybe you can go ahead and start while I'm erasing all this. Also, the marker makes my nose really itchy, and I just want to tell you how much I'm trying not to itch my nose right now. It's really, really hard. And it's just embarrassing to teach and itch your nose because, you guys will show this video to everybody and say that your professor picks their nose. All right, so here's the deal. This turtle was born in 1809, right? It is currently 2020, or at least when I make this video. If this video is presented to a future class, let's just pretend it's 2020, okay? What is the difference between those 2 years? Well, I have to say that the difference between those is 211 years? Yes, 211 years, right? So I want to find out what this is in hours. So I start over here, 211 years, right? And I want to get to how many hours alive this thing has been. Okay, well, what's the next closest unit from years to hours? Well, no big surprise, it's days. So we know that in 1 year, there's 365 days. Right? Cancel, cancel. I'm left with days. To get from days to hours, it's super easy. You know that in 1 day, I'm putting in the bottom so it'll cancel out with days on top over here. When 1 day, there's 24 hours. Okay? And gloriously, we can solve this problem. 211 years times 365 days times 24 hours divided by 1, divided by 1. And you get an answer of 1,848,360 hours. Ladies and gentlemen, that is a very old turtle. It's a very wise turtle. And I would love to ask it some questions about the meaning of life. Okay, lastly, I always end my slides with some link to a place where you can get extra practice. So obviously you guys have homework assignment this week. You guys have a lab this week, but there's going to be other opportunities to practice if you want other opportunities. One of them is this slide here that says, wait, where can I practice this stuff? Go ahead, practice it there if you feel like you want more practice. And there's also the adaptive practice that is inside our module. Okay, with that said, this has been a lovely first lecture. I hope it was valuable. I hope it was clear, and I'll see you later next week.